Alright, another type of equation that you need to remember how to solve is a radical. So for example, 2x equals the square root of 5x minus 1 plus 1. If you remember, the goal here is to get the radical to go away and then to solve for x. So the first thing we do is move the 1 to the other side, square both sides, but when you square this left side, you no longer are just squaring in each individual piece, rather you are multiplying 2x minus 1 times 2x minus 1. This gives us 4x squared minus 4x plus 1 equals 5x minus 1 because the radical and the square cancel. Then we get everything on one side. So this would be 4x squared minus 9x plus 2 is 0. And it gives us a quadratic equation. This brings up factoring, quadratic formula, completing the square, all those things that you need to know in order to solve a quadratic equation. What I'm going to do is try and slide and divide and factor it to see if that works. And if that doesn't, then we'll use the quadratic formula, because 9 is odd, so I do not want to complete the square. So remember, in slide and divide, you multiply the 4 over, so it gives us x squared minus 9x plus 8. We're looking for factors of 8 that give us negative 9. That would be negative 1 and negative 8. This then becomes x minus 1, x minus 8. I divide by the 4 that I originally slid, and this gives me 4x minus 1 and x minus 2 equals 0, making my solutions 1/4 or 2. Again, we check to see if any of these are extraneous, meaning if you plug them in, they do not work. So I have to plug them in my problem. So if I'm going to check, x is 1/4. 2 times 1/4, does it equal the square root of 5 times 1/4 minus 1 plus 1? So that's 1/2. Does it equal the square root of 5 over 4 minus 1 plus 1? Well, the square root of 5 over 4 minus 1 is the square root of 5 over 4 minus 4 over 4 if I find a common denominator. So that's 1/4 under the radical. In this case, the square root of 1 is 1, the square root of 4 is 2, plus a half. 1/2 plus 1 is not 1/2, so that one doesn't work. Then I go and check 2. 2 times 2, will it equal the square root of 5 times 2 minus 1 plus 1? So, does 4 equal the square root of 10 minus 1 plus 1? 4 does equal the square root of 9 plus 1. And hopefully you're seeing that, yes, it does. So 2 is your only option here. With that being said, quadratics are a big part of Math 2. However, they are in Math 3, and you do need to be able to recognize them. So if you remember, a quadratic can come in two different forms. Standard being y equals ax squared plus bx plus c, or vertex form, which is y equals a x minus h squared plus k. You need to be comfortable going back and forth between these two forms and being able to identify anything from a quadratic from them. That being the vertex, and that being the axis of symmetry, the y-intercept, telling me whether it opens up or down, has a maximum in, and all those wonderful details. You also need to be able to graph these. The key to graphing, at this point, if you don't know, is to plug in the calculator. And y equals. We've already talked about sliding and dividing, so with solving, make sure you use your techniques 1 of the quadratic formula. Remember, that formula always works. And that formula is x equals, because we're finding our x-intercepts, our solutions, the opposite of b plus or minus the square root b squared minus 4ac all over 2a, not just this radical over 2a. Remember, the most important part of this equation is the b squared minus 4ac. That is called our discriminant. Why is this important? Our discriminant will actually tell us how many solutions we have. If b squared minus 4ac is positive, there are 2 real solutions. If it equals 0, meaning the radical goes away, then there's only going to be 1 real solution. Then, lastly, if it's negative, there are going to be 2, everyone's favorite, imaginary solutions. So let's do an example using the quadratic formula just to make sure we know. If I wanted to solve 3x squared plus 7x minus 6, here our a is 3, b is 7, c negative 6. I'm going to plug it in my formula. So the opposite of b, plus or minus the square root b squared minus 4ac all over 2a. And I always plug everything in parentheses so that I don't forget something. So then negative 7 plus or minus the square root. Negative 7 squared is 49. This number will always be positive. 4 times 3 is 12. 12 times 6 is 72. And there are 2 minus signs, so that's plus 72. Then it's all over 6. 49 plus 72 is 121 over 6. You should know that the square root of 121 is 11. And then you solve your 2 problems. The first being negative 7 plus 11 over 6. That's 4 over 6, or 2/3. The second being negative 7 minus 11 over 6, negative 18 over 6, or negative 3. So there are your 2 solutions. If you chose to graph this in y equals, that is the numbers where it would cross the x-axis. Also, because these numbers are pretty decent, even though 2/3 is a fraction, that means that this problem is factorable, so you could have slide and divided it. Then remember, there's always another way, which is completing the square. Because this is a new topic for you, I would assume it would be on your final exam, being the county exam and the state exam, just because it's brand new. So an example to start off is x squared minus 6x plus 25 equals 0. This problem is not factorable because there are no factors of 25 that give us negative 6. You could use the quadratic formula, but because 25 is a little bit bigger, you might not want to. So we're going to complete the square. And remember the rules with completing the square. We're going to get our algebraic terms alone and move that 25 to the other side. So we're going to subtract 25. We're going to take our b term, divide it by 2, and square it. This number will get added to both sides of the equation to keep it balanced. That gives us x squared minus 6x plus 9 equals a negative 16. What this does in, quote, completing the square is make this quadratic equation perfect. What that means is the factors of 9 that give us negative 6 are the exact same number, being negative 3. So when I factor this, I get x minus 3 squared is negative 16. And if you recall, to undo a square, you simply just take the square root. That gives us x minus 3 equals the square root of negative 16 is plus or minus 4i. 4 being the square root of 16 and I being the negative part. This is an imaginary solution. Then my final answer would be 3 plus or minus 4i when I got x by itself. If you were to graph this in the calculator, this would not cross the x-axis ever because both solutions are imaginary. Again, you can use the quadratic formula if you want. It would reduce down to 3 plus 4i. Now, what if we had a number coefficient in front? 3x squared minus 6x plus 9. Here, if you notice, all three terms have 3 in common, so I would just simply divide it out and then complete the square from there. Or this might be factorable. Are there factors of 3 that give us -2? Nope. So you could use the quadratic formula or, again, completing the square on this one. Please remember, I is nothing more than the square root of -1, making I squared equal to -1. This will come up in simplifying radicals. It is just used in quadratics and solutions of quadratics and any other polynomial, really. Remember that the solutions can be called roots, zeros, or x-intercepts. You may be asked to find roots of all things. You may be given roots and asked to find equations. So for example, on that, let's look at, what if I told you, or your test told you, you have roots of 2 and 3i. First off, you're supposed to know that this is a cubic equation. Cubic, you might ask, there's only 2 solutions, so why is it not quadratic? Remember, imaginary and irrational always have a pair. One's positive, one's negative. When you take the square root, you have 2 solutions. So your real roots are 2, 3i, and -3i. We work backwards to solve this to create our equation, meaning if 2 is a solution, that means x minus 2 is a factor. If 3i is a solution, x minus 3i is a factor. And x plus 3i would be the factor of -3i. Then you use what we talked about at the very beginning and multiply this out. To make life easy, multiply the crazy parts together first, because the crazy parts end up canceling each other out. This becomes x minus 2 times x squared plus 9. Over here to the side, I will show you by fooling. X times x is x squared. Then you get -ix plus 3ix minus 9i squared. These cancel. X squared minus 9i squared. Remember, I squared is nothing more than -1. So this becomes x squared plus 9. Then you can simply multiply these two together. So that's x to the third minus 2x squared plus 9x minus 18. And ta-da, there's your polynomial. You may also be given this polynomial and ask for all the roots of it, which means you're going to work this way. So let's do an example of that. Say you have x to the third minus 4x squared plus 4x minus 16. And you're asked to find all the roots. There's a couple of ways you can go about this. You can first look to see if it factors and makes your life easier. You can type it in y equals and see where it crosses the x-axis and then divide it out. Completely up to you. This one is factorable, so you could factor by grouping, but just in case it wasn't, I want to show you on the calculator what you would do. So remember, y equals x to the third minus 4x squared plus 4x minus 16. Now look at this wonderful little picture. When it draws, I see right there it crosses at 4. I can double check in my table to see that it does cross at 4. So 4 is a solution. I know x equals 4. So then I'm going to use my synthetic division technique to find the other factors.